Heating a substance at certain temperatures will change its state. In other words, the substance will change between the solid, liquid and gas states. For example, if we take some water and heat it to increase its temperature, then once it reaches 100 degrees Celsius, the heat will make it boil, turning the liquid water into a gas. Then importantly, during the change of state, heating will not affect the temperature of the substance. This is a very important fact that students often forget about and get penalised for in an exam. So in this case, once the water starts boiling, then it will stay at 100 degrees Celsius until it has become a gas. The temperature of the liquid water can't increase past this point. But why does this happen? Well, during a change of state, the kinetic energy of molecules won't change. Remember that substances consist of molecules or particles that move or vibrate because they have kinetic energy, with the temperature of the substance being determined by this kinetic energy. Normally, when energy is supplied to the molecules as heat, their kinetic energy would increase. But during a change of state, this kinetic energy remains unchanged. So what happens to the energy we supply? Well, instead, the energy is used to weaken or break the bonds between molecules. Remember that the molecules will be held together by intermolecular bonds, which we can think of as springs that stretch or contract and let the molecules move. So when we're heating the substance during a change of state, all the energy from the heat will be given to these bonds instead of to the molecules to change their kinetic energy. Supplying the bonds with energy will gradually weaken them. Then when enough energy is given, the bonds will break. This won't happen to all the molecules at once though, so we still won't see a change in temperature until all the bonds have been broken. But will this mean the bonds are gone forever? Well, removing thermal energy will cause the bonds to reform. So if we were to say bring the molecules to a cold environment, then there would be a heat flow to the surroundings. This means that the molecules would be losing kinetic energy. But at a certain temperature, this loss of energy would instead make the bonds between them reform. So the fact we can undo the change that breaks the bonds means this is an example of a physical process. So when these bonds break or form, what would we notice about the system? The breaking or forming of bonds causes a change of state. Remember that we can find matter in 3 different states, depending on how their molecules are arranged. We have solids, where the molecules are held together by strong bonds and can't move much. Liquids, where the bonds are weaker and the molecules can flow around each other. And gases, where there are next to no bonds and the molecules can move freely. So when we change a solid to a liquid through melting, or change a liquid to a gas through boiling, what's happening is that the bonds are breaking. We supply energy to break the bonds and restrict the movement of the molecules less, meaning its state has changed. Then in reverse, when a gas changes to a liquid through condensation, or when a liquid changes to a solid through melting, what's happening is that the bonds are reforming. So the loss of energy is restricting the movement of the molecules again, meaning it has to change its structure accordingly. But what about the other ways to change state? That is sublimation, where a solid changes directly to a gas, or evaporation, where a liquid changes to a gas without a heat supply. Well, sublimation is something you won't be expected to explain at GCSE. But let's see how evaporation fits in with this idea. Liquids can evaporate by slowly taking in heat from the surroundings to break bonds without reaching a boiling point. So for example, if we wanted to remove the water from some wet washing by letting it change to a gas, we'd use evaporation, so we don't have to heat or burn our clothes. But how exactly does this work? Well, what's happening is that the water is slowly taking in energy as heat from the surroundings over time. This means the water eventually gains enough energy to change state, and so the clothes dry out. Then in terms of the molecules, what happens is that this heat they take in over time is given to their bonds, even though we're not at a boiling point. Eventually, the bonds will receive enough energy this way to break. Usually, only a few bonds will break at a time, which is why evaporation is a slow, gradual process. Now, in an exam, you wouldn't need to be able to explain how evaporation works in quite this much detail, but you do need to be aware that the liquid is taking in heat from the surroundings to cause a change of state. Let's also look at a common application of this that you could be asked to explain. Sweat helps us cool down by taking heat from our bodies for evaporation. So when we get warm, such as when we exercise, our bodies release liquid sweat in response. This sweat will take in heat from our bodies in order to break bonds and evaporate. In particular, the fact that the sweat is more actively taking in this heat for evaporation than the surrounding air means that our body temperature drops faster.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!